Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 2. This is Section 11.1, Problem number 2. It says, consider the function f of x equals x minus 1 times x minus 2, and then find three different limits for that function. So I have parts A, B, C. In part A, it says find the limit of the function x minus 1 times x minus 2 as x approaches 0. So as you put in things very close to 0, see what you're getting out. So there's no reason why we can't actually just put in the 0 for x. So what we're going to get, the x minus 1 becomes 0 minus 1. The x minus 2 will become 0 minus 2. And 0 minus 1 is really negative 1. 0 minus 2 is really negative 2. And the whole thing winds up boiling down to negative 1 times negative 2. The negative times the negative cancels, and we have an answer of positive 2. So as you put in input values very close to 0, you get an output or height on the graph very close to positive 2. That's part A. Part B, same function, different input value that we're taking the limit of. So we want to find the limit of x minus 1 times x minus 2 as the input value approaches positive 2. So as we approach positive 2, the x minus 1 gets very close to 2 minus 1. As the x approaches positive 2, the x minus 2 approaches 2 minus 2. 2 minus 1 is positive 1. 2 minus 2 is 0. 1 times 0, of course, is 0. So as our input values get very close to 2, so again, say 1.999, the output, or height on the graph, gets very close to 0. And finally, part C, we want to find the limit of x minus 1 times x minus 2, the same function. But now as the input value approaches negative 2, so we're going to put in values very close to negative 2, like negative 1.999. Negative 2.0001. So we can see what output we'd be getting by letting a 2 go in for x, a negative 2. So x minus 1 becomes negative 2 minus 1. And then the other parenthesis, x minus 2 becomes negative 2 minus 2. So now pay attention to your signs. Negative 2 minus 1 is negative 3. And then negative 2 minus 2 is negative 4. And then when we multiply negative 3 times negative 4, we get a positive 12. So as our input value gets very close to negative 2, as we get close to negative 2 on the x-axis of the graph, the height or the output, the y-coordinate, would get very close to a positive 12.